Now we discuss complex roots of characteristic polynomial. Second case, suppose alpha plus I beta is a root of characteristic polynomial z of r. In this case, the conjugate of this complex number, that is alpha minus I beta, is also a root. And the solution of L of y equal to 0 corresponding to this root is e raised to alpha plus I beta x. Okay, if R1 is root of characteristic polynomial, then e raised to R1x is solution of L of y equal to 0. Okay, so here R1 is alpha plus I beta. Now this is nothing but e raised to alpha x into e raised to I beta x, and e raised to I beta x is cos beta x plus I times sine beta x. Okay, so this is solution in complex plane. Okay, we want real solution. We try to get real solution from this. Okay, now given that this is solution of L of y equal to 0, so therefore L of e raised to alpha plus I beta x is 0. Okay, but this is nothing but L of e raised to alpha x into cos beta x plus I times e raised to alpha x into sine beta x. Now we already have seen that the operator L is linear, so this is nothing but L of e raised to alpha x into cos beta x plus I is constant, so I times L of e raised to alpha x into sine beta x. Okay, and this is equal to 0. Okay, so L of this plus I times L of this equal to 0. Okay, now e raised to alpha x cos beta x is a real function, so L of this is real number plus I times L of e raised to alpha x sine beta x, this is also real. Okay, so we can equate real and imaginary parts on both sides. Okay, left hand side is 0, 0 means 0 plus I times 0, so we can equate real and imaginary parts. Equating real and imaginary parts in this equation, we get two important expressions: L of e raised to alpha x into cos beta x equal to 0 and L of e raised to alpha x into sine beta x equal to 0. Okay, so this is a real part and second one is imaginary part in this equation. Both are 0. But this means e raised to alpha x into cos beta x is solution, as well as e raised to alpha x into sin beta x is solution. And note that these are real solutions. Okay. So earlier we were having e raised to alpha plus I beta into x as solution, which is complex solution. Here, equivalently, we get two real solutions. Okay, so we show that these two are linearly independent, and this can be used to form general solution. Okay, so to prove that these are linearly independent, we can find Wronskian. Okay, we have Wronskian of these two functions, e raised to alpha x cos beta x, e raised to alpha x sin beta x, equal to determinant. First row is these two functions, e raised to alpha x cos beta x, e raised to alpha x sin beta x. Second row is derivatives of these functions. So differentiation with respect to x, e raised to alpha x into differentiation of cos beta x, it is minus sin beta x into beta. Okay, so minus beta sin beta x plus cos beta x into derivative of e raised to alpha x, it is alpha e raised to alpha x. So we take e raised to alpha x common. So plus alpha cos beta x. Okay. Here differentiation of e raised to alpha x into sin beta x. It is e raised to alpha x into derivative of sin beta x. It is beta cos beta x, and then sin beta x derivative of e raised to alpha x is alpha e raised to alpha x. So plus alpha sin beta x. We have to find determinant of this. It is equal to e raised to 2 times alpha x into, it is beta into cos square beta x, then it is alpha cos beta x sin beta x, then minus, so let me write, plus alpha cos beta x into sin beta x, minus this, again e raised to 2 alpha x common, so minus, and this is again minus, so plus beta sin square beta x minus alpha cos beta x sin beta x. So this term gets cancelled. Okay, and beta cos square beta x plus beta sin square beta x is beta only. Okay, cos square beta x plus sin square beta x is 1. So this is beta e raised to 2 alpha x, and this is non-zero if beta is non-zero. Okay, of course we take beta non-zero. If beta is 0, then roots cannot be complex. Okay, our roots are alpha plus I beta. Beta should be non-zero, otherwise root is real number, which we already have considered. Okay, so these are linearly independent. Therefore, e raised to alpha x cos beta x and e raised to alpha x sin beta x are linearly independent solutions of L of y equal to 0 and can be used to find general solution. We see some examples. Example 1. Find general solution of y double dash plus 5y equal to 0. Here L of y is y double dash plus 5y. Therefore, characteristic equation is r square plus 5 equal to 0. Therefore, characteristic roots are, so we have r square equal to minus 5 and r equal to plus or minus square root minus 5. It is plus minus I times root 5. Okay, square root minus 1 is I. Therefore, we get complex conjugate roots. Okay, therefore there are complex conjugate roots alpha plus minus I beta with alpha equal to 0 and beta is square root 5. Okay, therefore general solution of L of y equal to 0 is y equal to, so these two solutions are e raised to alpha x cos beta x and e raised to alpha x sin beta x. Okay, so c1 into e raised to alpha x cos beta x plus c2 e raised to alpha x sin beta x. Alpha is 0, so e raised to 0 is 1. So this is c1 into cos beta is root 5 plus c2 sin root 5x. Okay, so this is a required solution. Next example, again find general solution. Problem is y double dash minus 4y dash plus 13y equal to 0. Okay, so L of y is y double dash minus 4y dash plus 13y, and therefore characteristic equation is r square minus 4r plus 13 equal to 0. We have to find roots of this quadratic equation. Okay, therefore r equal to minus 4, that is plus 4, plus minus square root 4 square 16 minus 4 into 13 divided by 2. Okay, so from this root we can take 4 common. So this is 4 plus minus, we take 4 outside, so it is 2 square root 4 into 4, 16 minus 13 divided by 2. And we can cancel 2 from this. So this is 2 plus minus this 2 gets cancelled, and this is square root 4 minus 13 is 9 and minus 9. So this is 2 plus minus I times square root of 9, that is 3. 2 plus minus 3i. Okay. So these are roots, and if we can call this as alpha plus minus I beta, where alpha is 2, beta is 3. Now we can write general solution. General solution of L of y equal to 0 is y equal to C1 e raised to alpha x cos beta x plus C2 e raised to alpha x sin beta x, that is y equal to C1 e raised to 2x cos 3x plus C2 e raised to 2x sin 3x. This is general solution. Thank you.